Mr. Beck does your homework. This is homework number 3, questions 9 and 10, a two-part problem. It says rocket-powered sleds are being used, we'll just say are used to test the responses of humans to acceleration. Starting from rest, one sled can reach a speed of 607 meters per second in 1.61 seconds and can be brought to a stop again in 2.46 seconds. Find the acceleration of the sled while accelerating. And then the next question, find the acceleration of the sled when braking. So what's really going on here? It sounds like there's a lot of information here. Starting from rest, that's one speed, or velocity of 0. My next speed is 607 meters per second. And then it can be brought to a stop again. So this sled is going through two different things of motion. So let's see, a rocket-powered sled. Let's draw a sled on some wheels. This will be my rocket engine. So let me give it some big rocket flames coming out the back. Rocket flames coming out the back. And this is to test humans. So here's my little helmet guy sitting here in the little chair. Just trust me, this is a little guy ready to be accelerated. Okay. And he's sitting on this chair. There we go. So there's my rocket-powered sled. So we are going to accelerate. So initially, I'm going to be going at 0 meters per second. At some time later on, that sled is going to be going really quick, and it's going to be going 607 meters per second. And then at some time later on, it's going to be brought to a stop again. So later on, this thing is at rest again. So it's again at 0 meters per second. So when I'm finding the acceleration of the sled while accelerating, well, that's going to be this first part of the question. And later on, I'm going to find the acceleration of the sled when braking. Well, that's going to be this second part of the question. So now I think I'm ready to go. So I just care about the 0 going up to 607 meters per second. So what I can identify is that my initial velocity is 0 meters per second. I also know that it can reach a speed of 600 meters per second in 1.61 seconds. So the time associated with the acceleration is going to be 1.61 seconds. And then it can be brought to a stop again in 2.46 seconds. So this time is going to be 2.46 seconds to go back to rest. Sorry about that. 2.46 seconds. So this is my acceleration, 0 to 607 in 1.61. Then my deceleration is going from 607 down to 0 in 2.46 seconds. So my initial velocity for this question number 9 is 0 meters per second. My final velocity is 607 meters per second. And my time is going to be 1.61 seconds. This is my question number 9, and I'm looking for my acceleration. So I know that my acceleration is going to be my change in velocity divided by the amount of time. It's going to be my change in velocity is my final velocity minus my initial velocity. So here my final velocity, divided by time. Here my final velocity is going to be the 607, because for this part of the problem I'm going from 0 up to 607. So that's my final velocity, 607. Minus my initial velocity is 0, and all of that divided by the amount of time is 1.61. And this is meters per second, and this is seconds. So if I do 607 minus 0 divided by 1.61, that's going to give me some answer, some number, and my units are going to be meters per second squared. And you'll notice this is going to be a positive number. I'm going from 0 to faster and faster and faster. So I'm going to get a positive number when I have this positive divided by this positive. So that's number 9, and that'll give me a positive meters per second squared. Now what's happening in question number 10? Well, question number 10 says find the acceleration of the sled when braking. So when braking, it's starting at 607 meters per second. So even though that was v for this question, that's actually where I'm starting for this question. So my initial velocity is going to be 607 meters per second. My final velocity is going to be 0 meters per second. And this time is 2.46 seconds. So t equals 2.46 seconds. It takes 2.46 seconds to go from 607 down to 0. So now if I write my acceleration is my final velocity minus my initial velocity divided by time. I'm going to get a final velocity of 0 minus an initial velocity of 607 divided by a time of 2.46 seconds. Now, this is going to be negative, isn't it? 0 minus 607 divided by 2.46. So that's a positive amount of time, but this acceleration is going to be negative, and negative acceleration happens when you're going at a positive velocity and you slow down. That's a negative acceleration. So my acceleration is going to be some number, and it's going to be a negative when I get that number. And my units, again, are going to be meters per second squared, because this is meters per second divided by seconds gives me meters per second squared. So there is your answer. Make sure it's negative.